Hey there, everyone. It is day 8, and I have a um, bad feeling that this is going to be a long one. Yesterday was sort of a long one. I have a bad feeling that this is going to be like an extremely long one, but let's hope that it is not, and let's get going. Um, right. Expedition comes across a peculiar patch of palm tall trees all planted in a grid. Displaying the previous expedition planted these trees reforestation effort. Now they shows the good location for a tree house. First, determine if there is enough tree cover. Do this, you need to count the trees that are visible from outside the grid when looking directly along a row of column. The elves offered um, have already launched a quadcopter generator map with height of each tree. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all the other trees between the edge of the grid are shorter than it. Only consider trees in the same row or column, that is, only look up, down, left, or right from any given tree. All the trees around the edge of the grid are visible. Since they are already on the edge, there are no trees to block the view. In this example, that leaves only the interior 9 trees to consider. The top left 5 is visible from the left and top. Is visible from the right or top? The top middle 5 is visible from the top and right. The top right 1 is not visible from any direction. For it to be visible, there would need to be only trees of height 0 between it and an edge. The left 5 is visible, but only from the right. Center 3 is not visible from any direction. 16 trees on the edge, another 5 total 20 trees. How many trees are visible from outside the grid? Okay. So that makes sense. Um, so let us do the following. Trees equals list x for x in raw. Okay, so now I have a list of x for x in raw dot split lines. Okay. Whoa, what happened? I don't know what I did there. That was interesting though. And let's see, trees. Seriously? Did I not save it? I think when I tried to save it, I did something else. And um, equals NC for C and X. That's why I do this. I'm live coding, yeah. Parse raw, which is a string, and is going to be a list of ints, and return int C for C and X. Okay, good. So let's say tree. So I'll do like that. Let's parse raw. And then what I want to do is the following. Def visibilities trees, which is a list of an int, which is going to be a list of a list of a list of strings. Okay, and so why am I doing it this way? Because a tree can be visible from each of 4 directions, and I don't want to have to worry about overcounting. Like if a tree's visible from the left and from the bottom, I'm going to count it twice, right? So what I'm going to do is I'm just going to keep track of what directions is each tree visible from, and this will be a little bit tedious, but then so let's say result equals for C in row for row in trees. Okay. What doesn't it like about this? Return res. What doesn't it like about this? Function with declared type none can be not. Okay, I had an imbalanced bracket. So now I'm going to do this because I don't want to take up that many lines. And so let me run it again and just make sure that this gives the right shape. Okay, good. That's what I want. Okay, so now what I want to do is I want to do each direction. And let's do and let's say nr equals len trees and nc equals len trees 0. Just these will be easier. Okay. Do each direction. Okay, so let's do left to right. Actually, let me do def visible trees, which is going to be a list of int, and it is going to return a list of ints. Okay. If the trees have the heights in order which are visible. Okay, and so let's say tallest equals -1, result equals this. For, and I'm going to actually make this list of bools just to make it easier. For tree in trees, if tree is bigger than tallest, res append true, tallest equals tree, else res append false, return res. Okay. Left to right. For row in range nr, for I visible in enumerate, visible trees are. If visible, res ri append l. Okay, what doesn't it like about this? Visible is possibly unbound. How is it possibly unbound? I just did a function there. Enumerate visible. Okay, right to left. Let's see if it can write this for me. For r in range this, trees are -1. If visible, res r nc -i-1 append r. I still don't know why it doesn't like this. How can it be possibly unbound? I defined it up here. Anyway, okay, top to bottom. Let's see if I can write this. For C in range NC, in enumerate visible row C for C in trees, if visible, that's fine. And then let's say bottom to top, for C in range and C for I visible. Okay, that's what I want it to do. Okay, perfect. So now local variable visible reference before. This is the problem because I gave it the same name as that. Visible. All right, it was trying to help me out and I wouldn't let it. Okay, let's try it again. Okay, so left top, 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 left, right, top, and then let's look at this thing. And just let me do this. Left top, 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 left, right, top, left only, left and top, but not bottom. And let me make sure I got that edge case right. The bottom, the top left 5 is visible from, okay. 16 trees, a total of 21 trees are visible in this arrangement. So that means there's 4 that aren't. So I have 1, 2, 3, 4. Okay, good. Def count visibilities, trees, which is going to be a list of lists, and it's going to int. Viz equals visibilities trees, return sum of, I don't want len x, I want bool of x. Assert that count visibilities of trees is 21. It's not 21. What did they say it was supposed to be? 21 V's. Okay. Let's see. 18. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Abilities trees. Let's see. Oh, because I changed. It's stupid. Because I modified this to read it easier. Okay, that was dumb. That was extremely dumb. Okay, so now that works. Good. So I think I did that right. So now let's get this and say that that's that. Okay, with open day08.text as f. Trees equals parse f.read. That's good. Print okay, good. So let's try this. 1792. That is the right answer. Okay, good. Content with the amount of tree cover available, they also need to know the best spot to build a tree house. They'd like to be able to just see a lot of trees. In terms of the viewing distance for a given tree, look up, down, left, and right. Stop if you reach an edge or the first tree that is the same height or taller than the tree under consideration. If a tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those found by the rules above. The proposed tree house has large eaves keeping it dry, so they won't be able to see higher. For example, consider the middle 5. Looking up, it's not blue. Blue is not blocked. Looking left, its blue is blocked immediately. It can only see one tree. Looking right, its view is not blocked. Looking down, its view is blocked. Eventually, you can see 2 trees, 3 and then 5, and then the tree of height. A tree's scenic score is found by multiplying its viewing distance in each of the 4 directions. How we do even better? Consider the tree of height 5. Looking up, its blue view is blocked at 2 trees by another tree with a height of 5. Looking left, its view is not blocked. It can see 2 trees. Looking down, its view is not blocked. It can see 1 tree. Looking right, its view is blocked at 2 trees. This tree scenic score is 8. Highest scenic score. Okay, viewing distance. Look up, down, stop if you reach an edge at the first tree that is the same height or taller than the tree. If the tree is right on the edge, at least one of its viewing distances will be 0. Okay, so def viewing distance, trees, which is a list of int, and let's say I, which is an int, and j, which is an int, and that is going to return a list of ints. Okay, and so I don't need to do any of these, but I need to do nr equals len trees and nc equals len trees there. That's good. Okay, and let's say let's go left first. So say vd equals 0. For I underscore, and let's say, I original j equals ij, because I'm going to modify them. Vd equals 0. And let's say while I is bigger than 0, and let's say h equals trees ij, while I is bigger than 0 and trees, no, left is j. So while j is bigger than 0 and trees I, j, let's say, so go until you see the first tree that is the same height or taller than, so let's say while j equals 0, let's say j minus equals 1, vd plus equals 1, if trees ij is bigger than or equal to h, break. Okay. And now let's do right ij equals original I, original j. Let's say, again, result is that. Res.append. Actually, we need to do this outside. So let's do ij vd equals original I, original j 0. While j is less than nc minus 1, j plus equals 1 if tree is ij. Okay, so I think that's right. Now let's do up. Okay, that seems right. While I is bigger than 0. Okay, subtract 1 from I, add 1 to the viewing distance if the tree is that break, and I need to put this here too. That's good, and now let's do down. Okay, well, I is less than nr minus 1, I plus equals 1, we do, yeah, so that seems good too. Yep, and I need that, and I need to put that here as well, and then just return res. Okay, so let's run this. Viewing distance trees 0, 0 is 0, 3, 0, 6. Now let's go look at this. Consider the middle 5 in the second row. So now let us, that is 2, sorry, that's 1, 2. So let me do row 1, column 2, and it says 1, 1, 1, 1. Looking up, its view is not blocked. You can see 1. Looking right, its view, looking left, it's blocked immediately. It can see 1. Looking down, its view is blocked eventually. It can see 2. And looking right, it can see 2. Okay, so it is not working properly. Print ij vd trees ij h. And we'll see what I did wrong. And this is right. This is up. And this is down. And so we'll see what I did wrong. What is H here? H equals trees ij. So let's look at, hold on. I wonder if this is the problem. 1, 2, 1, 2. Okay, so the issue was that I put the wrong array in. So that's real smart of me. So now let me comment out all these print statements. So my logic was probably correct. I just ran it on the input rather than my test input. And this is left, right, top, bottom. So if I go left 1, right 2, top 1, bottom 2. Okay, tree of type 5 in the middle of the fourth row. So this is 0, 1, 2, 3, 2. So let's do 3, 2, and that's 2, 2, 2, 1. That's the ideal spots. Okay, so now def best location, trees, and that's going to be, sure, that's right. That's not right. Return max product viewing distance trees ij. Does they introduce product in some version of Python? Is it this one? No, it is not. So def product x's okay, good. Return max of product of viewing distance trees ij. Okay. For I in range and R, for J in range and C. Okay, let's do that. Assert the best location for trees is 108. I'm sure it's not. And it is 8. So let's run that and see if that works. Okay, that worked good. Print best location for trees, and let's see how that does. It gives me an extra parentheses. 334,880. So let's try that and see if it works. That's the right answer. Okay, cool. So that worked. So what did we do here? Besides being verbose, so we parsed it into a list of lists. That's good. Then I said I need to figure out how many trees are visible from outside, right? And so what I did was I recognized that it was going to be a pain in the butt to try and disambiguate, okay, this is visible from the left and from the top, and I don't want to count it twice. So what I did is I said, I'll just make a list of the direction that every tree is visible from, right? So trees from visible from the, and I'll just check each direction. And then I'll just look and say how many trees have a direction from which they are visible. And then I said, this visible trees logic, all I really, for each direction, I just need to like go through the values in order, keep track of what is the highest one that I've seen, and if I'm taller than that, then I'll get seen. Otherwise, I won't get seen, right? So that logic is here, and it's not too complicated. And then what I just need to do is I need to go in each of the four directions, right? Left to right, right to left. Copilot wrote a lot of those for me after I wrote the first one. So that was good. And then I just need to count. I use bool because that'll be basically true if a list is not empty, false if a list is empty. When you sum up trues and falses, you get 1 to 0. So basically it's saying sum up a 1 for every time you have a non-empty list of directions that a tree can be seen from, and 0 for whatever. So that worked. And then for part 2, it just wanted me to do this sort of arbitrary thing. There's probably a better way of doing it than how I did it, but the way I did it worked, and you know, relatively straightforward. So took a little bit, sup, and then it works. So that's that for today, and I will see you, I guess, tomorrow, maybe not. It's Friday. Who knows what it'll be.